In today's video, I'm going to show you an example of a failed USB flash drive. So this is a 64 gigabyte SanDisk USB 2.0 USB flash drive, and I had it for a number of years. I think I bought it back in 2019 or 2020. I've used it a great deal because I use it for work. I have to copy large files to it and back and forth, Probably I've used it many thousands of times in the past 3 years. And the problem that I have with it is I can't delete or erase information from it. As you can see, it gives me no option to do this, and when I press delete, I can't delete anything from here. Also, I cannot copy any information into here as well. So if I try to copy something, it won't let me. It says disk is write protected. However, it is not this write protected at all. There's no write protection on a flash drive like a floppy disk drive or something like that. And I can't send any files. I can't write to this flash drive. I can't erase anything from the flash drive. And if I try to format the flash drive, it will not let me do that either, which I will demonstrate. It says again, the disk is write protected. So I can't format it because formatting means erasing it, right? So I can't erase it. And I'll explain to you why flash drives fail. And one of the reasons is flash drives have a limited number of write cycles. Before we had flash drives, we had something called ROM, which is called read-only memory. If you grew up in the 1980s and if you ever played some Nintendo games, or if you had a computer back in the 1980s or 1990s, you used to have something called a ROM chip. And basically the way you could save onto a ROM chip was by having a battery on it. So it's kind of like the RAM on your computer. So right now my computer is on, so the RAM is working. So the RAM is storing the memory that it's getting from the storage device, which in this case is the operating system, which displays everything here. So all of this goes into the RAM as temporary memory. We would call that volatile memory. And after I turn this off, or turn this computer off and turn it back on again, everything would be erased because there's no power. So back in the 1980s, I had a game called The Legend of Zelda. You were able to save to it because it had a small lithium battery. I think it's a CR2032 battery, and that enabled you to save to the ROM cartridge. And this is also true for motherboards, which have BIOSes as well. The BIOSes, you could save the BIOS settings with the battery. So if the battery dies, then you will lose your setting. So I'll explain to you why the flash drive fails like this. So obviously this is a dead flash drive. However, I can read information. I could read from this flash drive and copy it onto my hard drive, let's say. That's possible. I could do that. And the reason why I can't write to it and erase or format or do anything is because the way flash memory works, it's kind of like It works like a transistor. For a transistor, I think on is 1 and off is 0. So the way this works is when you put current through this, you have a dielectrical or oxide layer here, and the electrons the electric current gets trapped in here. So you apply voltage, a certain amount of voltage is applied to the transistor, and that will regulate how much, whether that state would be on, which is 1, or off. So depending on the voltage, it would be on and off. So the energy goes into this float gate, which regulates the amount of electric current that goes into the transistor, which enables you to save your information. And this is just a very simplistic way of explaining it. And as time goes by, this oxide layer wears out, right? So as a result, electric current doesn't go into the float gate, which means the electric current can't be regulated, right? So as a result, if this fails, you're not able to erase or write to the NAND memory chip anymore. So that's why it fails. Over time, this oxide layer fails. You know, it's kind of like I guess a filter. The more you use a filter, the more it gets clogged up, right? And if it gets too clogged up, then there's no water flow from the filter. Works by having the water flow through the filter, right? So if it gets clogged, then you're not going to get anything through the filter, so the filter doesn't work. It's kind of like that kind of principle, like that. So this no longer works. This also holds true for other type of flash memory, like micro SD cards, SSDs, and stuff like that. So they all have a limited write cycle. And oxide, like I showed you on that diagram, the oxide layer fails, which prevents the transistor from regulating the electric current, and this prevents it from writing, reading, or changing, or even changing the file. So I can't even change the file here. I can't even rename this. But on here I can rename it. See, I could rename it right here. I can't do anything here. So it says it's write protected, but it's not really write protected. It's just, it doesn't have the ability to be used anymore. So that's what I want to share with you today. What I do with flash drives is I always keep a backup of the flash drive in a hard drive or other devices, just in case. But most of the times when a SSD or flash drive fails, you simply just won't be able to write to it, erase it, or change any of the files in it. So it can no longer read. I mean, it could read, but it can't write to it, change any of the files. That's the only thing. You're still going to be able to read from it. So basically, it became a ROM memory. It became like ROM memory, kind of like back in the old days, back in the 1980s and 70s, we used to have ROM cartridges for like the Atari 2600, Atari 5200, Atari 7800, Commodore 64, Nintendo Entertainment System, Sega Master System, Sega Genesis, or whatever. So you can't write to a ROM cartridge, right? Unless you have like a battery, which enables you to save the settings. So basically now this drive right here, this flash drive, you know, if I want to, you know, I may not want to just throw this away now because it's got some important information in here, right? So the only way I can dispose of it is by physically destroying this, by taking a hammer or something, or putting it in a acid solution and dissolving it or whatever. I can't get rid of the data in here by erasing it because it no longer writes to it or erases or does anything. So that's what I wanted to share with you, and if you have any thoughts, you could leave it in the comment section below, and thanks